Hi guys, so today we're going to do the skeletal system. That's chapter 7. Let's just do a quick overview. We'll talk about the different components. We'll go over the different types of bone. And you have compact bone, which is basically the outer bone, and the functional unit of compact bone is the osteon. And we'll also talk about spongy bone. And spongy bone is basically the inner bone, and it's made up of these little spicules or trabeculae. And we'll talk about cartilage, tendons, and also ligaments. Now, it's also important to note the different functions the skeletal system provides. One of those is just support. Without our bones, we would have basically no posture. It provides protection. So, like your skull bones protect the brain. It acts sort of like armor. It provides movement. Your muscles attach to your bones and allow for movement. Hemopoiesis, which is blood building. That happens in the bone marrow. That's where we build red blood cells, white blood cells. That's where they all start from. Mineral storage. We get calcium and phosphate. And also we have storage of energy in the skeletal system. There's actually lots of fat within your bones. All right. So in your body, your bones come in many different shapes and sizes, and they're put in these basic categories. The long bone, you talked about this in lab, and I will expect that you know the different parts of a long bone. And I just want to point out some key features here. So now towards the end of the long bones, we have the epiphyseal plates. So that's this portion right here. And it is an epiphyseal plate when the long bones are still growing. And remember, it turns into a line after the long bones stopped growing. So the epiphyseal plate is made up of a type of cartilage, and that type of cartilage is hyaline cartilage. And all the bones are surrounded by this protective sheath, and it's called periosteum. Peri means around, osteum refers to bone. Now, in this particular spot that surrounds the cartilage, if it is the epiphyseal plate, we call it something different. We call it perichondrium because it's not bone, it's cartilage, so it's called perichondrium. Now, when that epiphyseal plate turns into an epiphyseal line, that cartilage turns into compact bone, and that outer protective sheath is now the periosteum. So that's the long bone. I will ask you questions from the long bone. But we also have other types of bones. We have flat bones. An example of your flat bone would be the sternum. We have irregular bones, which an example of that would be your vertebrae. Short bones, like your carpal bones in your wrist. And then also sesamoid bones. The best example of a sesamoid bone is the patella. And sesamoid bones, those are embedded in tendons, and your patella is embedded in your quadricep tendon. So in this next picture, let's talk about the cells of the bone. Here we have a cross-section of the long bone, and we have the general location of where these cells are actually found. Osteoprogenitor cells are found on the outer portion of the long bone, and these are stem cells. These are stem bone cells. Now, these stem bone cells then will become osteoblasts, which are the bone building cells, and they manufacture the bone, and eventually they will turn into osteocytes, which are the mature bone cells. And those osteoblasts basically get trapped inside a matrix and begin to build the compact bone. And also, we also have the osteoclasts. And osteoclasts break down bone. Okay, so they eat away at the bone. Let's take a closer look at the outer portion here. And we can see we have the protective sheath of the bone, the periosteum. And if we peel that back, we can see where we have some of these osteoprogenitor cells. And remember, those are the stem cells. And those osteoprogenitor cells will make or become osteoblasts, which build bone and produce this, basically, these functional units called osteons. And osteons, they have all of these osteocytes here. These little white circles, these are all osteocytes that have become trapped inside of their matrix of bone. Okay, we also have blood vessels here in red and blue that we can see that bone is actually a vascular tissue. Your periosteum is also pain sensitive, which means that there's going to be a nerve supply. So we could actually draw a nerve here as well. Okay, so I would know for sure that the osteon is the functional unit, particularly of compact bone. So before we move on to bone formation and growth, let's review some bone histology, and let's begin with the cells found in bone. Remember, we have stem cells, and often refer to stem cells as mesenchymal. And mesenchymal stem cells just mean that it's coming from connective tissue, which bone is. And specifically, if it is bone, then we call those stem cells osteoprogenitor cells. And those are bone stem cells. Those osteoprogenitor cells then become osteoblasts that build bone. And what happens is that osteoblast becomes trapped in its lacuna as it's churning out bone matrix. And once it does, it is now an osteocyte. So all of these cells come from osteoprogenitor. However, we do have one more cell that actually does not come from an osteoprogenitor cell, and that is an osteoclast. And remember what these cells do, they break down bone, and they look sort of like this, kind of wonky looking with multiple nuclei, sort of like a googly-eyed looking monster. And it's actually a type of macrophage. And remember, that's the symbol for macrophage. Macrophage is a white blood cell that eats away at things, which an osteoclast does. It eats away at the bone matrix. All right, so those are the cells found in bone. Now, the matrix is made up of ground substance and fibers. The matrix has an osteoid component, which gives bone its flexibility, and it's made specifically by the osteoblast. The hydroxyapatite gives bone its mineral or hardness. And you don't want too much of either of these. You don't want your bones to be too flexible or too hard. You want a good balance of these for strong bones. Okay. And then we have fibers, and you do have collagen fibers found in bone as well. Since collagen is the most abundant protein found in the body, you are not surprised that it's actually found in bone as well. Okay, so don't worry about this part. Just make sure that you know the cells and what is found in the matrix of the bones. Let's go on to bone formation and growth. So we talked about bone formation in Chapter 5. So I would review Chapter 5. That was the tissues chapter. The section that goes over intramembranous ossification. And then also endochondral ossification. Okay, so that goes over bone formation. So bone growth, bone formation, we deal with bone deposition and bone reabsorption. Bone deposition is putting down bone, okay, or building of bone. And we can expect that we would have an increase of osteoblasts during this. This would also include bone bumps, and bone bumps develop in areas that experience extra weight or stress or extra force. So let's say you got kicked in the shin multiple times. Over time, you may notice that you actually feel a bump in your shin. That is a bone bump, and it's extra laying down of bone to make that certain area stronger. Now, in contrast, we have bone reabsorption, and we would expect that we would have an increase of osteoclast activity. So what that has to do with our nutrients in the blood, our first scenario here, if we have an increase in osteoblast activity, we would expect, look down here, that we would get a decrease in calcium concentration in the blood. Now in our second scenario, if we have bone reabsorption and our osteoclast increase, then we would expect to see number 2 here. We would see a increase in calcium concentration in the blood. Now as our bones grow, they can grow in 2 different ways, either appositional or interstitial. If the growth is appositional, that means the growth is happening on the surface of the bone. So what we have here is a cross-section of bone, and we see the bone cell splitting off, making more bone cells, and the growth is on the surface. So not from the middle, but in the surface. And what happens is then the bone grows in diameter, or increases in diameter. Now, interstitial growth happens in the middle. To put this in perspective, this is the type of growth that happens at the epiphyseal plates. This is how we get taller. And in reality, this is actually cartilage growth, but that cartilage then will turn into bone, so we still include it in bone growth. In this picture, we have a cartilage cell, which remember is a chondrocyte, but it begins as a chondroblast. And that chondroblast churns out this matrix, becomes trapped, and then turns into a chondrocyte. Okay, and this again is the type of growth that happens at the epiphyseal plate. So make sure you know the difference. Appositional on the surface, interstitial in the middle, and then example would be the type that happens at the epiphyseal plate, and this is how we get an increase in length versus an increase in diameter. So hormones play a vital role in bone growth, particularly with calcium and calcium reabsorption. So let's look at 2 scenarios here. The first one is a low calcium concentration in the plasma, and what that does is it goes on to stimulate the parathyroid glands. And remember, those glands are located on the posterior backside of the thyroid gland, the one in the neck. And you can have anywhere from 3 to, I think, almost 5 seed-like glands on the back of the neck. And it stimulates the parathyroid glands to secrete parathyroid hormone, also known as PTH. And then this can cause an increase in osteoclast activity, and it causes calcium and phosphate to be released into the blood. And in turn, what this does is increase calcium concentration in the plasma, counteracting our original stimulus of low calcium in the plasma. So on the flip side, let's say our stimulus is an increase in calcium in the plasma. This goes on to stimulate the thyroid gland. That's the gland located on the anterior surface of the throat. And it causes the thyroid to secrete calcitonin. And calcitonin causes a decrease in osteoclast activity and an increase in calcium secretion by the kidneys, meaning the kidneys are acting to get rid of calcium. And in turn, this decreases calcium concentration in the plasma. And this fixes our original stimulus of an increase in calcium in the plasma. Another hormone that plays a role in calcium regulation is vitamin D. And we can get vitamin D in numerous ways, either from the sun or from certain foods. So the sun interacts with certain steroids and cholesterols found in the skin, and they actually make this very first molecule here, cholecalciferol, which is D3, and then it goes on to the liver, processed by the liver, turns into calcidiol, and then it gets processed by the kidneys and turns into calcitriol. Now this is the actual active form of vitamin D3 that we can actually use. This step right here, from calcidiol to calcitriol with a T, can actually be increased or can be sped up by the addition of this hormone. Remember, PTH, that stands for parathyroid hormone. It can speed up, increase the reaction rate of this step right here, from calcidiol to calcitriol. And what this ends up doing, erase this arrow right here, what calcitriol does is it increases calcium concentration and phosphate concentration in the plasma. So let's just review these hormone effects real quick. So if we had a decrease in calcium in the plasma, the parathyroid gland would then release PTH, increases osteoclast activity, and we end up with a net effect of decreasing phosphate, which is PO4, and increasing calcium in the plasma. Now, if we have an increase in calcium in the plasma, the thyroid gland then releases calcitonin. That causes a decrease in osteoclast activity, and we end up with a net effect of decreasing phosphate and decreasing calcium. I think I wrote this part wrong in your notes, so make sure you fix that. Now in vitamin D3, or the active form, calcitriol, make sure you know that. This causes an increase in calcium absorption, causing a net effect of an increase of calcium and phosphate in the plasma. So here we just go over some additional hormones that contribute to either bone loss or bone growth. Like growth hormone, particularly it plays a role in chondrocytes. It can increase at linear growth, which are chondrocytes, and also an increase in osteoblasts. Thyroid hormone, it works in unison with growth hormone. You need a healthy balance between the two because it helps to stimulate bone growth by influencing the metabolic rate of bone cells. So you need a balance between growth hormone and thyroid hormone for healthy bone growth. Sex hormone, like testosterone and estrogen, increases after puberty, and it dramatically accelerates bone growth and cartilage at the epiphyseal plate. Okay, growth plates close more quickly, actually, in response to estrogen. Glucocorticoids, like cortisol, coming from the adrenal glands, these help to regulate blood glucose. High amounts of these can contribute to an increase in blood or bone loss. Serotonin. You actually have receptors for serotonin on bone that help to regulate normal bone remodeling. If you have too many or too high number of these, it can contribute to too much bone growth. So in this last page, let's go over a few bone disorders. Let's talk first about this one right here, osteopenia. Osteopenia is a lower than normal BMD, and BMD stands for bone mineral density. Okay, bone mineral density. You end up with thinner or weaker bones, a demineralization of bones. That just means a loss of calcium or minerals. Who's affected? Typically, it can start as early those years between 35 and 40 years of age. However, osteopenia is not as severe as that called osteoporosis. And osteoporosis is a decrease in bone mass. You end up with very thin and fragile bones. It decreases osteoblast activity. You get a decrease in estrogen. This is estrogen right here. In turn, you have an increase in osteoclast activity and an increase in PTH. Remember, that stands for parathyroid hormone. Particularly who are affected the most by osteoporosis, and that's postmenopausal women. Partly due to the decrease in estrogen. And then finally we have what's called osteomalacia, and that's a loss of bone salts, but not the collagen, the fibers found in bone. Typically this is due to poor diet, and you end up with a decreased absorption of calcium and vitamin D. You can also see this with people that have rickets, which can be seen in young children, and also those not properly exposed to sunlight, so inadequate exposure to sunlight, like those seen in the housebound elderly that maybe don't get outside enough. You could end up with osteomalacia and not get enough vitamin D, basically. Okay, so those are the 3 bone disorders we were going over. All right, so that concludes Chapter 7 lecture. Happy studying. That's it.